Section 12.5, Triple Integrals, Video 4. In the previous video, we talked about what was called a type 1 solid, where our solid was bounded above by a surface, below by a surface, and then we had the solid in between, and then the projection of it onto the xy plane was the region over which we evaluated a double integral. A type 2 solid is kind of the same thing, but oriented differently, where we have a solid bounded on the right, and I'm sorry, instead of saying on the right, we should say on the front, if you will, by some function x equals u2 of yz, and on the back by some other function x equals u1 of yz. So imagine that this board is the yz plane. Then what we would have are two surfaces that are up in front of each other and behind each other in the x direction. So we have this surface in front, another surface in the back, and then the solid is captured in between them. So I tried to draw them here, not without much luck. And then because these are functions of y and z, meaning we go over a y over a z, and then our front function tells us how far out to go to the front, and our back function tells us how far out to go to the back. Because it's a function of y and z, then the projection of this would be onto the yz plane. So if you can imagine a light source sitting in front of this, and all the light running parallel to the x-axis, then the projection onto the yz plane would be the shadow that this solid would create. So how do you set up a triple integral for a type 2 solid? Well, you always integrate with respect to the variable that is a function of the other two first. In this case, we have x1, the back, and x2 as functions of y and z. So we would evaluate the integral dx first, and we would integrate that from the back to the front, from the lesser to the greater. So u1 of yz and u2 of yz. In fact, it's a dead giveaway that if you have a function of two variables defining opposite sides of the solid, your first integral will be with respect to the third variable. So since these functions are functions of y and z, our first integral will be dx. And then once you evaluate that integral, then you can just evaluate the double integral over the region projected onto the other plane, in this case the xy plane, and that would be a dA. So integrate the function with respect to the variable that is equal to the functions that define the, in this case, front and back, so with respect to x. And then once you evaluate that, do the double integral. Now, how you do the double integral depends upon how this region is defined. For example, if this region were defined on the top by z equals some function h2 of y. In other words, go over y and the function will tell you how far up to go. And then the one on the bottom is defined by z equals h1 of y. And then along the y-axis, let's just say this is defined from a to b. Then to evaluate that double integral, so we got the first integral from u1 to u2, let's just write u1 and u2 for brevity. To evaluate this double integral, we would have to evaluate it with respect to z first, and then with respect to y last. You always go from highest to lowest dimensions. So the top of this is defined by h2 of y, and the bottom is defined by h1 of y. So we would do the dy integral next. And then we would do the dz integral last. Excuse me, that's the dz integral. You can never integrate with respect to a variable that's in your limit of integration. You can't integrate with respect to y if you have y's here. You can't integrate with respect to y or z if you have y or z's here, which is why we're doing dx. But our last one would be dy, and it's evaluated from a to b. Now, of course, that's assuming that this region in the xy plane is defined above and below by functions, and then over some interval in the y-axis. Vice versa, if it were defined on the left and the right by functions of z, then we would do a dy integral, and then we would do dz last. So it takes a little while to get accustomed to how to set up a triple integral relative to the definition of the region. We'll take a look at the type 3 solid in the next video, but imagine you can see what it's going to be like. The first solid, type 1, was we had surfaces in the z direction and then projection down into the xy plane. The second solid was we had surfaces in the x direction and it got projected on the yz plane. So you can imagine that the next one will have surfaces in the y direction and it will project onto the xz plane. So no big surprise.